Hello everybody. In this video I want to talk a bit about electrolytes. And basically the whole idea of electrolytes really is just a different way of talking about a phenomenon that we've already seen. So first we have our strong electrolytes. An example of that would be like sodium chloride dissolving out into aqueous solution where it forms sodium ions and chloride ions. What makes it strong is that strong electrolytes dissolve readily in water and they dissociate nearly completely into ions. So we're going to have very little sodium still bound to chlorine, and instead we're going to have free sodium and chloride ions. Having these ions in solution is going to lead to a conductive solution. So when these ions are free to move throughout the solution, they can conduct electricity. Weak electrolytes, like weak acids, only partially dissolve in water, and these could actually be acids because, as we saw before, it's just a special case of the exact same thing. Acids form into protons and a conjugate base, so an anion and a cation. It's just a special case because the cation happens to be a free proton in the case of an acid. So here we have acetic acid. This is the acid that makes up vinegar. It is an organic acid, and organic acids tend to be weak acids, and so they're also weak electrolytes. A significant portion is going to remain in this bonded form when added to water, and another portion of it is going to go ahead and ionize. And we denote that by, instead of just having a single arrow pointing towards the ions, but having this back and forth arrow here that indicates that there's an equilibrium between these two. And forming fewer ions leads to a less conductive solution when you dissolve the same amount, i.e. moles of a weak electrolyte versus a strong electrolyte. The same molarity of solution is going to lead to less conductivity when you have a weak electrolyte. And we're going to non-electrolytes are those that will dissolve in water but don't dissociate into ions. It's not true that everything has to dissociate out into an ion. A very classic example of that would be like sugar. So this would be like sucrose, regular table sugar, C6H12O6 as a solid. It's going to go into solution and form an aqueous solution. We know that we can fit quite a bit of sugar into a solution, but it will not ionize, and therefore it will not increase the conductivity of the solution. We talked a little bit about this before, but I want to give you guys a little review of why it is that ions form in water. And basically what's happening is it is the water molecules that are helping to stabilize these ions, where we have dipoles with their partial negative charges that are going to face towards all our cations, surrounding it and stabilizing that positive charge. And in the same way, we're going to have our dipoles align away from our anions with these partial positive charges on the hydrogens, stabilizing the negative charge on the anion. It is important to remember for your homework that solvation is a physical process, and that solvation of ionic compounds increases disorder and therefore entropy.